Okay, so what I wanted to try and do is just give a little bit of an explanation and a kind of overview of where we are with freshwater in New Zealand, and inevitably going to talk about the skullduggery and cover-ups that go on between what's the reality and what gets presented. And I kind of have to explain some basics first to get my point across, I think. So I just quickly wanted to show this just to keep people in mind about just how much we've changed the landscape and how much our rivers and lakes are kind of under pressure before we start adding any nutrients into the system. So this is just a bit at the bottom of the North Island there where I work, showing pre-European land cover, basically three colours there: wetlands, native forest and dunes. And this is what it looks like now. So we've now got a purple colour, the dunes are gone, we've got exotic forestry, but basically it's all farmland. But the crucial thing I wanted to show you there, remember, about a third of it was wetlands. That's where the wetland is now. 99% of the wetlands gone, and this is pretty much the story for the whole country. And the point I wanted to make was it's not just all of the really important, beautiful habitats and all that kind of thing, but the functions of wetlands and the nutrients, their ability to take up nutrients and to be able to absorb floods and do all the things they do for us for nothing, and how we've lost that. Okay, so we all know about how much vegetation's been gone. I think some of us don't realise just how much has been lost from farmland. So a huge amount of the native land cover was on farmland, and that's disappeared. Places like Canterbury, where all of the red parts of the map there are less than 10%. Canterbury less than 1% of the cover. Just how much it's not 100% pure New Zealand. It's 100% pure Europe, basically. 68% of our ecosystems are listed as threatened, like threatened species, are threatened with extinction. And what's happened really recently, so that was building up to now. Now what about the last 20 odd years? Twice as many cows in the country, but crucially 4 times the production from those cows. So just to put a little bit of context around this eternal argument of whether it's the cows that are the problem in our rivers or it's the humans that are the problem in our rivers, just to look at the 6.8 million dairy cows there are now, if you think about the impacts being equivalent to at least 14 humans, then you're looking at least 90 million human equivalents with that cattle, with that number of dairy cows. So forget all the other cows and beef stock and all that kind of thing, just dairy. 90 million versus 4 million, and that's going to give you some idea of the ratio. But the crucial part of that is the 4 times production hasn't come from anything other than bringing in stuff. So huge amounts of nitrogen fertiliser increase. We're the biggest importers of palm kernel of any country in the world to feed those cows, and this is the thing to understand. That our landscape wouldn't support that many cows. It couldn't support anywhere near that many cows if it wasn't for the feed that we bring into them. And the nutrients. And we need to be totally aware that the planetary boundary for nitrogen we're twice over the planetary boundary as globally of the planetary boundary for nitrogen. That is, humans now create more nitrogen than natural sources do. So we completely changed this nitrogen balance, and the issue with that is that it all ends up in our rivers and lakes and causes the problems that I'll go into later on. So we've just got way more cows than the land or waterways can handle. Lakes, 44% of our lakes are considered polluted. That means that this is from the 2008 study, and very hard to get these details now. Apparently the 112 lakes that were monitored are no longer monitored because the money isn't there for them. I heard the other day that the 77 rivers that have been monitored that I'll talk about, that NIWA have been doing for 20-25 years, the funding's disappearing for that as well. But in 2008, when this last work was done, 44% of them had flipped into another state. That meant that they can't handle the nutrients that are in there. They've gone into another situation, and most of those lakes are in lowland areas. So 43% of our lakes are pristine, but they're in the conservation state. We just haven't touched them. That's why they're pristine. Anything that's in the lowlands is in trouble. And there's the normal suite of issues there. Algal and cyanobacteria blooms, sedimentation happening, which I'll talk about for the rivers as well, and the pathogens for human health issues. So the consequences of all of this happening, and particularly in the last couple of decades, are The sedimentation, the build-up of rivers and river beds, the loss of habitat that happens from that, the fact that you have to keep stop banking rivers and you have to keep spending huge amounts of money on maintaining them to keep them in the bed so they don't do damage. It doesn't, crucial that you understand that it doesn't end in our rivers. Just because we don't happen to monitor our estuaries and offshore environments doesn't mean that the impacts aren't being felt out there. And the work that has been done has shown that our ocean fisheries in particular are affected by the sedimentation of our estuaries. Work that I've done in my students on native fish show that it's crucial, those in-stream habitats that are being lost to sedimentation, and it's all about deposited sediment causing the problems, not what's measured, which is suspended sediment, but what ends up on the beds of the rivers and fills up the interstitial spaces. Crucial habitat for our native species, and we don't measure it, we don't assess it, and it's not part of any new assessment either. What I'm mainly going to concentrate on, because it's the big issue, it's hard to say what's the biggest issue, it depends where you are, but nitrogen in our rivers is a big issue, maybe one of the biggest. And it's what it does in the rivers that I want to explain. It's not the direct effect of the nitrogen, it's not the nitrogen poisoning the life, it's the nitrogen causing excess growth of algae and cyanobacteria and the effects that has on the life, as well as just obviously smothering the bed. But I want to try and this is the bit that gets confused, and I wanted to try and show this. I've got this kind of line up the side there, which is nitrogen levels in milligrams per milliliter in the water. The ANZAC guidelines is the Australian and New Zealand kind of accepted guideline. They accepted science up until a few years ago with the Land and Water Forum. This is the level at which, if you get over that point, you start to get these algal mats forming, like the picture on the right. And to give you an idea of a real-life example, you get a little bit over that to the Manawatu River at Hopelands Road, where it's 1.2 milligrams per litre, and you get this fluctuation of oxygen levels that you see. See that graph with the squiggly lines going up and down? The most extreme swings there are Hopelands Road and the Manawatu River. So much algae in mats like those pictures there at certain times of the year that oxygen fluctuates over a 24-hour period from 30% dissolved oxygen at 3 o'clock in the morning to 120 up to 160 in the afternoon. Way too bigger extremes for any life to be able to handle. I mean, if you went and measured it at lunchtime, it would be fine, and that's the problem. What you miss is the swing. Those swings have a measure around them that freshwater scientists use in a number of countries around the world. The more extreme the swing, the more extreme the number. So 0 to 3, the little index that comes out of it, is a healthy river. 3 to 7 is a satisfactory river. Anything greater than 7 is considered impacted. Manawatu River has regularly scored over 100, and nowhere else in the world, that's been measured over 570 sites that Cawthron pulled together. The highest anywhere else in the world was 60 below a wastewater treatment plant in Germany. So this is the kind of swings and fluctuations you get at 1.2 milligrams in the Manawatu River. And I just want, because I'll come back to these numbers and I'll show you again and put it into context. The WHO, the World Health Organization, safe limit for nitrate, nitrogen in water is 12.3. This is the level that causes the blue baby syndrome. I don't know if Alice is going to talk about this, but adult humans could handle way more than that. But there's this kind of weird thing that if people think that if it's acceptable for drinking water, then it must be good for everything else. But it's not. It's a long way from being good for everything else, and it's a ploy that's used by deniers. Okay, so how does this look for the whole country? There's that trigger level, the ANZAC guidelines. So everything that's red and orange in this map, this predictive map from NIWA, and those coloured blotches there are actually river lines, and we just model out over these lines. The black dots are the sample sites, and the modelling fills in the gaps between them. So you can see there, pretty much everywhere intensive farming in New Zealand exceeds that guideline. So Southland, Canterbury, Hawke's Bay, Manawatu, Taranaki and Waikato, you can see in the reds there. Here's another map showing total nitrogen, similar pictures, similar places. The little graph I've got at the bottom is the 77 rivers that NEMO have been monitoring for 20 years now, so going back from the 90s till now. The upper red squiggly line is the pasture sites. You can see they're just increasing over time. The bottom is the non-pasture sites, and they're pretty much down around a few percent there. What I'm plotting is the percentage of sites, or percentage of samples within the year that exceed that guideline. So you're looking at sort of 30% back in the 90s up to about 45 or 50% now, and increasing. There's another way of looking at it there. What I did here was just plot all the sites, and I picked the years 2005 to 2011. I've got more recent data than 2011, but what's happened is the councils have started pulling their bad sites out of the data sets. Because of Lava Land and Water Aotearoa, they obviously know that these sites are going to go public now, so we just magically see all the bad ones starting to be disappearing from the data set and not monitoring them anymore. But so the darker colours there, 70 to 100% of the time they exceed it, and then up to the lower ones, I haven't included the ones that didn't exceed it, so they've all exceeded at some time during that time. The graph there shows the dark line at the top is the number of proportion of sites that exceed that number over the years, the same 30 years worth of data from 900 sites around New Zealand, and you can see that the breaches just keep on increasing over time. The red line down the bottom, so up to 67% of the sites now exceeding. The red line at the bottom is native sites, 1 or 2% exceeding and not going up, just showing you at the background levels that there's no change in nitrogen levels. Okay, phosphorus, the other crucial component of growing all this weed. You can see that there has been some improvement. Look at the graph at the bottom, there's been improvement over time at the pasture sites, but crucially, there's also been improvement at the non-pasture sites. So any claims for management improvements just aren't backed up because there's some natural thing happening with a decrease in phosphorus. The functional impacts are not particularly real because there can be not much phosphorus in the water column, but there's plenty of phosphorus in the substrate, so the algae can still grow. But that's just to show you. Anyway, this is using the biological monitoring. This is the invertebrates. These are the critters that have got to survive in the river. This is the accepted science around the world for how to measure ecosystem health of rivers, is to look at the biology. So everywhere that's dark red or orange is either severely or moderately polluted under the MCI. So this is 100% pure New Zealand you're looking at here. Look at that spread. Classically, West Coast, South Island, Coromandel, Kawekas, those kind of places, perfect. Okay, let's move along, have my sign. Now we go to human health, pathogen levels, same kind of graph. These are all the places that the dark blacks there exceed that human health limit. 70 to 100% of the time, that's the 260 coliforms per litre, units per litre, which is the Ministry of Health guidelines. Here we go, that other map again, same places where it's happening, that's the Ministry of Health guideline. We also, keeping on human health, we have world records now for the highest frequency per capita of these waterborne diseases. Huge numbers of New Zealanders contracting this. I mean, the proof is in the pudding that we've got problems around there. The other thing was these black cyanobacteria mats that grow on the rocks. These are the things that are killing dogs and horses around the country when they lick this stuff, and I think it's only a matter of time before a kid's playing in the street and they put that stuff in their mouths, and we have dead kids as well. Of course, you see it in biodiversity loss, huge increases there in the number of proportion of threatened freshwater fish. That bottom graph there, in the last 20 years we've gone from 20% threatened to 74% threatened. Higher ratio than I can find anywhere else in the world. These are the real indicators of the problems that we've got. I think I jumped a whole lot there, didn't I? Okay, I am going to jump through because I wanted to talk about the government responses to what's going on here, and there's the picture of the government responding to it there. But crucially, I wanted to talk about this report that came out in 2013 before the election that said our rivers are mostly stable or improving, and I wanted to point out what rubbish it is. And if you use the same test that they used there, the bit that they're calling stable, I applied the same test to population growth just to show you what this is like, according to that same test, global human population has been stable for the last 3 years. Because it's about the number of data points. They narrow down the amount of time, then there's no statistical difference, and they call that stable. It's not stable. Most of the sites were getting worse. They used the test over a short period of time and got non-significance. For any of you statisticians, a classic type 1 statistical error. And that Ministry for the Environment knew full well after I told them. They refused to take it down. They refused to front up on national radio when I talked to Catherine Ryan about it. Just classic examples of the denial from them. And this is the crucial bit now, is about the shifting of the goalpost from Ministry for the Environment. So here's that graph, my graph before. I was showing you where those levels were, and now we look at those bands are the new National Objectives Framework bands. So that place that was the worst in the world on the Manawatu River scores a B under our new system. The toxicity level is now 6.9, that's the bottom line for the country, because fish die at that level. But hang on, they were already dead because of the oxygen fluctuation. It's just a con. The nitrate toxicity level does not matter because all of the ecosystem's effects, the oxygen fluctuation that killed the life, happened at much lower levels than that. It's just a cover-up. The Mississippi River and the Yangtze River score a B under this system. And my time's up, but I'm really going to rush through it. And there's the Canterbury Water Management Strategy, right in the middle of that C band there, just a joke. And quickly, there over that side is all the places that fail the nitrate level, all those red levels that Matt you saw before. On the right is the new limits where the whole country now scores an A. So that solved that problem. Human health problem. See all the places that failed the Ministry of Health. Here's our new, we all score an A under this new system. We've gone from 260 coliform units to 1,000 is the new limit. So suddenly everywhere's an A. And we don't measure any of those things. And I just wanted to say quickly that we're starting a campaign to do something about this. Marnie's here somewhere. Marnie, stand up Marnie, talk to Marnie about our campaign. And Sophie's here somewhere as well. Talk to Marnie and Sophie. And go to those web pages there and sign up. There's a lot going to happen about getting rid of the knob. Sorry for going so long.